Hi everyone, and welcome to MathSux. This video is going to help you pass the Geometry Common Core Regents. We're doing this one question at a time. Here is question 1. A plane intersects a sphere. Which two-dimensional shape is formed by this cross-section? So here's a sphere. It's like a 3D circle. And they're saying if we had a two-dimensional shape that was just like kind of taken out of this sphere, what would we end up with? So if we were just to kind of take out one little slice of our sphere, it would look something like this, which is a circle. Choice number 4. Question number 2. The endpoints of AB are A, -5, 3, B, 7, -5. Point P is on AB such that AP to PB is 3 to 1. What are the coordinates of point P? So these questions, they follow a certain formula, so all we have to do is know the formula. So we're going to do the formula 2 times, once for x and once for y. So the formula, let me write it down for x, is x sub 1 plus a over a plus b times x2 minus x1. And then we're going to do it later for y, so I'm just going to put this line here. So what are these values here? So they gave us all these values. So we're just going to label them. So A, let's say, is x1, y1. B is x2, y2. And then they gave us this ratio 3 to 1. And we're just going to say A and B. So 3 is A and 1 is B. So now we're just going to fill this in. So for x1, we have -5 plus A, 3 over A plus B, 3 plus 1, times x2, 7 minus x1, -5. So minus -5, we're going to get a plus 5. And then we're just going to do some math here, and you end up getting 4. So right away you could see that our answer is going to be choice 4, but let's do the other part and find y as well. So we're going to do the same exact formula, but now with y. So instead of x1, it's going to be y1 plus a over a plus b times y2 minus y1. And we're just going to fill this in again. So y1 is 3 plus a, 3 over a plus b, 3 plus 1, times y2, -5, minus y1, which is 3. And then you can plug this in your calculator, or just do the arithmetic in your head, or one step at a time, and you'll get -3. So we know x is equal to 4 and y is equal to -3. Choice 4. Question number 3. Zach placed the foot of an extension ladder 8 feet from the base of the house and extended the ladder 25 feet to reach the house. To the nearest degree, what is the measure of the angle the ladder makes with the ground? So we're going to draw a little picture. So we have our ladder is being leaned against the house. This is like our house. And then this is the ladder. And this is the ground. An extension ladder 8 feet from the base of the house. So 8 feet from the base of the house, so we're down here. So down here we're going to label this 8. Extended the ladder 25 feet to reach the house. Ladder is 25 feet. The hypotenuse is 25 feet. To the nearest degree, what is the measure of the angle the ladder makes with the ground? So the ladder with the ground, we're over here. We want the value of this angle, so I'm just going to put angle theta here. So to do this, we're going to use some trigonometry. So we're going to write out SOHCAHTOA. In reference to this angle, we have the adjacent value and the hypotenuse. So we need one of the functions. We need the function that has the adjacent and the hypotenuse, which would be cosine. So we want to find the cosine of theta that is equal to the adjacent 8 over the hypotenuse 25. So to do that, we're just going to do the cosine. We can plug this in our calculators. Cosine to the -1 of 8, 25, and then let's see what we get. So let's get our calculator out. And when you're doing trigonometry like this in your calculator, you just want to make sure you're in degree mode. And then we're going to go second cosine 8 divided by 25. And we get this long number here, 71 Notice they want it to the nearest degree. So that's easy. We're just going to round to the nearest degree. So we get 71.33, and it goes on. But this is really just going to be 71 degrees that they're looking for, which is choice number 3. Question number 4. Darnell models a cup with the cylinder below. He measured the diameter of the cup to be 10 centimeters and the height to be 9 centimeters. If Darnell fills the cup with water to a height of 8 centimeters, what is the volume of the water in the cup to the nearest cubic centimeter? So this one's a little tricky because we're finding the volume of a cylinder, but we don't want to just take the values they give us here in the diagram. We have this cylinder is 9 centimeters tall. But what they want to know about the volume of the water in the cup, which is at 8 centimeters tall. So we really want to find this value at 8 centimeters. So now let's just keep that in mind when we find the volume of a cylinder. The formula pi r squared h. So we have pi, and then our radius up here, so the diameter is 10 centimeters, so we just want half of that for the radius, which is 5. So we have 5 squared times the height, which is 8. And when you plug that in your calculator, you're going to get 200 pi. And if you plug that in, you'll get about 628 centimeters cubed, which is choice 1. Question number 5. Which quadrilateral has diagonals that are always perpendicular? So we want to remember it's diagonals we're thinking of that are always perpendicular. So the rectangle, if you think of a rectangle, we know that the corners are perpendicular, but if we did this with the diagonals, notice they don't look like they're perpendicular. They're not perpendicular. Trapezoid, so we know that's not the answer. Trapezoid, they can be different shapes too. That's one shape of a trapezoid. Here's an asymmetrical trapezoid. So if they can be different shapes, that doesn't seem like a reliable thing to say that they're going to be perpendicular. Parallelogram, same issue. It's going to happen here. So even if we can't really imagine is going to be perpendicular or not, with these kind of questions, you really just have to kind of memorize and practice and study the rules of each of the shapes. And in this case, it's a rhombus that has perpendicular diagonals. Which regular polygon would carry onto itself after a rotation of 300 degrees about its center? So with this question, we want to see if each of these shapes can be rotated evenly by 300 degrees. So to do that, if we divide 360 degrees by the number of sides each shape has, it'll tell us the minimum turns it needs for the shape to map onto itself. So let's do that first. So how many sides are in a decagon? There's 10. So if we divide 360 degrees by 10 sides, we're going to get 36 degrees. So this number represents the minimum number of turns for it to move onto itself. So we're not even addressing the question yet. It's just one step at a time. And a nonagon has 9 sides. So 360 degrees divided by 9 sides is going to give us 40 degrees. And I'm just going to do this all around for each shape. 360 divided by 8 will give us 45. And then divided by 6 for a hexagon is 60 degrees. So these numbers represent the minimum number of turns for each of these shapes to turn onto itself. So now to deal with this 300 degrees. So what we want to do here is see if any of these numbers divide easily by 300. And if they don't, then that means they're not going to carry on to itself. So if we take 300 and divide it by 36, notice we get these decimal points, so it's not even. So here, this is not going to be our answer. Let's try the next one. So if we do 300 divided by 40 degrees, we get 7.5. That's a nicer looking decimal, but it's still not a perfect whole number, which is what we need, so that's not our answer. Let's try the next one. This also is a decimal. That's not dividing evenly by 300 degrees. And now the last one, 300 divided by 60, is going to be 5. So that's our answer. So that means we can turn the hexagon 5 times by 60 degrees and it'll turn onto itself perfectly. And that'll be a rotation of 300 degrees. And that's our answer. Question number 7. The rectangle drawn below is continuously rotated about side S. Which three-dimensional figure is formed by this rotation? So here's side S. So if we were to continuously rotate this rectangle, just imagine it's being rotated about this. So we have one this way, one this way. Notice we would get a cylinder. So the choice is choice number 3, cylinder. Question number 8. An equation of the line perpendicular to the line whose equation is 4x minus 5y equals 6 and passes through the point -2, 3 is what? So we're given a line perpendicular, so we know we're going to be finding the negative reciprocal of the slope of the equation they give us. So let's take the equation they give us, 4x minus 5y equals 6, and find the slope. So the slope of this line, we're just going to put it into y equals mx plus b form, where m is the slope. So let's move things around a little bit here. So notice our slope for this equation is 4/5. So if we want the negative reciprocal, so we're going to flip and negate this. So it's 4/5. We're going to flip it and negate it. So we're going to get from 4/5 to -5/4. And this will make the line perpendicular if we flip and negate the slope. So our new slope for this new line is going to be -5/4. And they gave us the point, it's going to go through the point -2, 3. And then we just need to put it into point slope form. So point slope form is y minus y1 equals m times x minus x1, where the point they gave us represents x1, y1. So putting this all together, we get y minus y1, which is 3, equal to the slope -5/4 times x minus x1, so minus -2 will give us x plus 2. And here's our answer, y minus 3 equals -5/4 times x plus 2, which is choice number 2. Question number 9. In circle P below, diameter AC and radius BP are drawn such that angle APB is equal to 110 degrees. If AC equals 12, so this diameter here is equal to 12, what is the area of the shaded sector BPC? So we're looking at BPC in here, BPC. So since this is a diameter, we know this is diameter, gave us that AC is drawn. We know that this entire angle here is going to have to add up to 180 degrees. So to do that, to find this missing angle here, which we're going to need to find the area of the shaded region, we're just going to do 180 degrees minus 110 degrees to get 70 degrees. Okay, so now we can find the area of the shaded region. So the area of the shaded region, or the area of a sector of a circle, is very similar to the area of a circle, the regular area. It's going to be pi r squared multiplied times a fraction of x degrees divided by 360 degrees. So that x degrees is going to be the value that's the angle within the shaded region. So in this case, it's 70 degrees. So we're going to have pi times r squared, so the diameter is 12, so half of that is going to be 6 squared, times x degrees, 70 degrees, over 360. And then we could just plug this into our calculator. And we're going to get 7 pi. And we don't have to simplify it any further. If you look at the answer series, you'll see choice 2, 7 pi is our answer. Question number 10. In triangle ABC, side BC is extended through C to D. If angle A is 30 degrees and angle ACD is 110 degrees, what is the longest side of triangle ABC? So there's a lot of information here. Let's draw a little picture out. So our picture might be right, might be wrong. I'm just gonna draw a little something, get a sketch going. So if you look at this, it says angle A is 30 degrees. So I'm gonna call this angle A up here. It says BC is extended through C to D. So we're gonna have B, C to D. So we have an external point here on D. If angle A is 30 degrees and angle ACD is 110 degrees, what is the longest side of triangle ABC? So it looks like it's this side from our picture, but we have to make sure, we have to check. So how do we know what the longest side is? It's going to be across from the largest angle. So the longest side So let's see what's here. These angles are going to be supplementary. So this is going to be 70 degrees. Just taking 180 minus 110 will give us 70 degrees here. And then within the interior angles of a triangle, we know that they're going to have to add to 180. So we're just going to add 70 plus 30, subtract that by 180, and you'll get 80 degrees. So now we need to ask ourselves, which is the largest angle within the triangle? And you could see that that's this angle 80 here, and the longest side is going to be across from that, which is side AC. Choice 1. Our picture was kind of right. It's really more something like this. Question 11. Right triangle ACT has angle A equals 90 degrees. So let's draw this out. Angle A has 90 degrees. C and angles T. Which expression is always equivalent to cosine of T? So let's write out SOHCAHTOA. So cosine of T. So if we're looking at T, so just to make our lives easier, let's just make up some numbers that go with this right triangle. So there's different triples to choose from, but I'm going to do 3, 4, 5, just so we have numbers to play with. It'll be easier to solve this problem. So if we look at cosine of T, we're looking at the adjacent, which is 3, over the hypotenuse, which is 5. So that'll be our goal when we're looking at these answer choices, to find something that's equal to 3/5. So if we look at cosine of C, so now we're looking at cosine of C over here, we're looking at the adjacent, 4, over the hypotenuse, 5. So we know that's not equal to 3/5, so that's not our answer. Now let's look at sine of C. So we're up here again looking at sine of C. So we're looking at the opposite, 3, over the hypotenuse, which is 5. So those two match, so that's our answer. So just to map out a little more clearly what we're looking at, this is sine of C over here, where we have the opposite, which is 3, over the hypotenuse. Question number 12. A regular pyramid with a square base is made of solid glass. It has a base area of 36 centimeters squared and a height of 10 centimeters. If the density of glass is 2.7 grams per cubic centimeter, the mass of the pyramid in grams is what? So I'm just going to draw a little picture. Not that you even need to. Square base. It says the base area is 36 centimeters and a height of 10 centimeters. And then we have a density of 2.7 grams. Okay, so we just need to find the volume of this. Which is equal to 1/3 times base area times height. Okay, and then we're going to multiply that 2.7 grams to convert this into the units they want. So we have 1/3 times the base area, which they gave us, 36 centimeters squared, times the height, 10 centimeters. And then in this case, in this problem, we're multiplying times 2.7. So we'll just plug that into our calculator and let's see what we get. And we get 324, which is choice number 2. Yeah, so just be careful with this 2.7 grams. In this problem, where that's what they want us to convert this by. But if you're just looking for the volume of the square base pyramid, it would just be this first part of the formula. Question number 13. The equation of a circle is x squared plus y squared plus 12x equals negative 27. What are the coordinates of the center and the length of the radius of the circle? So let's write this down here. X squared plus y squared plus 12x equals negative 27. And what we're going to be doing here is completing the square 2 times. So we're going to complete the square once with x, and then we'll see if we have to do it for y. It doesn't look like it though. So first we're going to move all the x variables together. So we have x squared plus 12x plus y squared equals negative 27. And I'm just going to focus over here. I'm going to complete the square, I'm going to divide 12 divided by 2 to get 6, and then square this value, which gives us 36. So we have x squared plus 12x now plus 36 plus y squared. That's going to stay the same. We're not going to have to complete the square since there's only a y squared here and there's no other term with just a y. Equals negative 27. And then we added a 36 here, so we're going to add it to the other side also. Yeah, completing square has a ton of weird rules. Please check out, I have a ton of practice questions on that if you want to check that out. Now we're going to rewrite this part of the equation as x plus 6 squared plus y squared equals negative 27 plus 36, which just gives us 9. And now this is our equation, but they're not asking for our equation. They want to know what the center and the radius are. So the center is going to be minus 6. So this is a positive 6, so we're going to do a minus 6, comma, a 0. There's nothing else here for y. And then for the radius, it's going to be radical of what's to the right of the equal sign. So radical 9, which will just give us 3. So our center is negative 6, 0 with a radius of 3, which is choice 3. Question 14. In triangle ABC below, D is a point on AB and E is a point on AC, such that DE is parallel to BC. So DE is parallel to BC. AD is equal to 12. DB is equal to 8. EC is 10. And they want to know what is the length of AC. So they want to know the length of this whole thing. So I'm going to call AE x, and AC will be 10 plus x. To answer this kind of problem is actually really nice and easy. Since it was given that these two are parallel, we know that these two triangles are going to be similar to each other. So when I say two triangles, I mean the little one up here, ADE, and then the bigger one, ABC. So the reason they're similar to each other is because notice they share this angle A here, so they have one angle that's the same. And then since these two lines are parallel to each other, it's kind of like AB and AC are transversal, so we know that corresponding angles are going to be congruent to each other, so that means angle D will be congruent to angle B, and angle E will be congruent to angle C. So we know that these two triangles are similar to each other by angle. So what that means is that the sides are going to be in proportion to each other. So knowing that, we can set up a proportion. And there's different ways you can set this up, but I'm going to just look at this original diagram we have over here and do this really nice and easy. We can do 12 over 8 is equal to x over 10, and then just cross multiply to solve for x. So remember, we're not just trying to find x, we're trying to find the length of AC. So AC, if you look back, is 10 plus x. So 10 plus 15 is going to be 25. Choice number 4. I also have a ton of questions on similar triangles, so please check that out. Question number 15. In the diagram below, point E is located inside square ABCD such that triangle ABE is equilateral and CE is drawn. What is angle BEC? So we're trying to find this angle, and we were given that triangle ABE is equilateral, so that means it's going to be equal on all sides. So it's equal over here all around, but it's also equal to the entire lengths of the square all around. Another thing about equilateral triangles, the angles are all equal to each other. So if we did 180 divided by 3, this is going to be 60 degrees all the way around. And we know that the angle left over in here is going to have to be 30 degrees because it's going to have to add up to 90 since this is a square and all interior angles add up to 90 degrees. So we have 30 degrees here, and notice on our triangle BEC we have marked that these two sides are equal to each other based on what they gave us, that this is an equilateral triangle. So we know that these two sides are equal to each other, so that means these two angles are going to be equal to each other too, because this is an isosceles triangle. So we have 30 degrees up here. We know that the interior angles of a triangle will have to add up to 180, so we're going to do 180 minus 30 degrees. We get 150 degrees, so we have 150 degrees left for these two angles to be, and we know they're going to have to be even, so we're going to just take 150 and divide it by 2, and we get 75 degrees. So angle BEC over here is 75 degrees, choice 3. Question 16. In the diagram below of quadrilateral ADBE, DE is the perpendicular bisector of AB. So DE is the perpendicular bisector of AB. So that means if it's bisecting and it's perpendicular, it's going to form a right angle and cut this segment in half. So AC will be equal to CB. Which statement is always true? So before we even look at the statements down here, notice what we have going on in here. So look at these two triangles up here. Triangle ADC and triangle CBD. Notice that they share a side, and we were told that this is a perpendicular bisector. So we have a side, an angle, and another side. So we could say that triangle ADC is congruent to triangle DCD by side, angle, side. And you could say the same thing down here. Triangle ACE over here is congruent to triangle BCE by side, angle, side. So knowing that, we know there's going to be a lot of congruent parts that form because of this congruent relationship. So if we look at the first answer choice, 1, ADC, they're saying ADC over here is congruent to angle BDC over here. So is that true? Yeah, that is true based on what we mentioned here first. The first one, triangle ADC, congruent to DCB by side, angle, side. So choice 1 is our answer. But let's go through the other answers to see why they don't work out. So if we look at angle EAC and say it's congruent to angle DAC, so we actually don't know if that's true based on this information here, because these two saying they're congruent triangles from here to here and here to here, but if we're comparing up to down, we actually don't know about that. So that's why that's not our answer. And the same thing goes for choices 3 and 4. If you look at AD to BE, they're on opposite sides of this shape, of this image, so we're not sure about that. AE to AD, again, one is down here, one is up here, so those are not our answers. So choice 1 is our answer. Question 17. What is the image of 4, 3 after reflection over the line y equals 1? So I'm going to sketch out a little coordinate plane for this question. So it says the image of 4, 3. So we have 4, 3, our original point, I'll just label it P, after reflection over the line y equals 1. So the line y equals 1 is over here. It's a straight horizontal line. And we're going to reflect this point over it. So to reflect over this point, let's just we're just going to imagine we're folding this in half and taking the mirror image of it. So let's see how many units away we are from this line, this point. So we have 1, 2. So we're 2 units away from this line, above the line. Now let's go 2 units below the line. So we have 1, 2. And this is going to be our new point of reflection, which if we look is 1, 2, 3, 4, and then down 1. So minus 1. So our answer is 4 minus 1. Choice 3. Question 18. In the diagram below, a cone has a diameter of 16 inches and a slant height of 17 inches. So this is a slant height. We have to be careful with that. What is the volume of the cone? So the volume of a cone is equal to 1/3 pi r squared times h. But we have to be careful here because notice this is the slant and not the actual height of the cone. So to find the height of the cone, we're just going to do a little Pythagorean theorem because notice this is a right triangle here. So we know that the hypotenuse has a value of 17. Up here, this is the diameter, so we're just going to want to take the radius for this triangle. So just dividing 16 divided by 2, which will give us 8. And now we could do the Pythagorean theorem, a squared plus b squared equals c squared, to figure out this missing value here. So we have 8 squared plus x squared equals 17 squared. And we get x is equal to 15. So the height of this cone is 15. So now we could go back over here and fill in our volume of a cone. So we have 1/3 pi times the radius, which is 8, half of that diameter. So we have 8 squared times the height, which we now know is 15. And plug this into our calculator. And we get 320 pi, which is choice 1. Question 19. In the diagram below, lines L and M intersect lines N and P to create the shaded quadrilateral as shown. Which congruent statement would be sufficient to prove the quadrilateral is a parallelogram? So we want to say that the shaded region is a parallelogram. And to do that, we're going to need to prove that lines L and M are parallel, and also prove that lines N and P are parallel. So this is just based on the different properties of a parallelogram. There's several different properties, but in this case that's the one we're going to be needing based on the information given, because we only have information on the angles. The way for the angles to be congruent to each other and have all these different angle relationships is to prove that these lines are transversals and parallel to each other, so that all those relationships can be possible and congruent. So we're looking for those corresponding angles, the alternate interior angles, and all the different angle relationships that transversals make. Answer choice. Let's go one by one through this and see what makes the most sense. So if we look at choice 1, it says angle 1 is congruent to angle 6. Okay, that looks good. And angle 9 is congruent to angle 14. So both of these look correct and great, but notice that it completely ignores line P, so that's not going to be our answer. Let's look at the next answer choice. Angle 5 is congruent to angle 10. Okay, that's an alternate interior angle. That proves L is parallel to M. And then angle 6 is congruent to angle 9. So this is, again, proving that line L is parallel to line M but completely ignores line P, so this is not going to be our answer. Okay, choice 3. Angle 5 is congruent to angle 7. Okay, so we have angle 5 to 7. So now we're involving line P. So this tells us line N is parallel to line P. It also says angle 10 down here is congruent to angle 15. Angle 15. So again, this is N to P. But now we're ignoring line L and M because these relationships of congruency don't line up with L to M. So this is not the answer. So by process of elimination, it has to be choice 4, but let's look at why. If we look at angle 6 to angle 9 down over here, so that this is by alternate interior angles. This shows line L is parallel to line M. And then over here, angle 9, so we're using angle 9 again, is congruent to angle 11. So now see, we're going up, down, and across, so now we're involving line P. And this is by corresponding angles. That line N is going to be parallel to line P. So it checks both our boxes of what we need to prove, so choice 4 is our answer. Question 20. In the circle below, secants TSR and TMH intersect at T. SR is 5, HM is 9, TM is 3, and TS is X. Which equation could be used to find the value of X? So here, notice we have two intersecting secants coming from T. So to find this value that they're asking for, we're going to use the intersecting secants theorem. So all that states is that TS times TR is equal to TM times TH. So you see we have this pattern of the first part of our secant times the whole thing is equal to the other first part of our secant that's on the outside times the whole thing. So let's fill this in. So we have TS is equal to X times TR, which is 5 plus X, is equal to TM, which is 3, times all of TH, which is 9 plus 3, which will give us 12. So now we get X times 5 plus X is equal to 3 times 12, which is 36. And now we just need to look for that in our answer choice. So notice that choice 1 is going to match our answer. Question 21. On the set of axes below, the coordinates of 3 vertices of trapezoid ABCD are 2, 1. So I'm just going to label each of these points. B is 5, 4. And D is negative 2, 3. Which point could be vertex C? So if we have a trapezoid, there's certain rules about trapezoids, right? So the thing about trapezoids is that we're going to have a pair of parallel sides. D is going to have to be parallel to DA. So we're going to want it to have the same slope. So DA will have to be parallel to BC, which means they're going to have the same slope. So let's look at what the slope is of DA. So let's take the coordinates of DA. So D is negative 2, 3, and A is 2, 1. And then to find the slope, remember it's just the change in y over the change in x. So this will be 3 minus 1, or negative 2 minus 2, which will just give us 2 over negative 4, or negative 1/2. So that's the slope we're going to be looking for when we look at these coordinate points. So if we look at point 1, 5, do you think that's going to give us a parallel line, a parallel slope to DA? It doesn't look like it. So choice 1 is not our answer. Okay, let's try the next one. 2 is 410. All the way up here. All the way up here. Does this look like it's parallel to DA? No, that's not our answer. Choice number 3, -1, 6. It looks like it might be parallel to AD. Let's see. So let's work on this on the side here. So to check if it's parallel, what we're gonna do is take the point B, which we know is 5, 4, and then this potential point C, -1, 6, and just find the slope and see if it matches what we got earlier. Change in y over the change in x. So that's going to give us 6 minus 4, or -1 minus 5. So it's close, but that is not the answer. Our slope here is -1. So this is not the answer. So by process of elimination, it has to be choice 4, but let's double check and make sure this answer makes sense. So if we have B, and then our potential right answer, -3, 8, and we find the slope, change in y over the change in x, it's going to be 8 minus 4 over -3 minus 5. So here we notice we get the right answer, the right slope, -1/2. So let's draw it out. So that looks like these are parallel now, DA to CB, and choice 4 is our answer. Question 22. In the diagram below, triangle ABC is congruent to triangle DEC. Which transformation will map triangle ABC onto DEC? And then we have all these different options. So a rotation. So if you think about rotating ABC, notice that the triangle is really facing a different direction. If we rotated it this way, just a rotation, it isn't enough to map it onto the other triangle DEC. So a line reflection. So this kind of looks like a line reflection, right? It looks like something's happening across point C. If we were to draw a line diagonally through point C, the answer here is choice 2, a line reflection. And if you look at the other choices, you can see they're not going to be correct. Choice 3 has a translation, which means we're going to be moving it left or right or up or down, followed by dilation, which would make the triangle bigger or smaller. So we know that that's not the answer. We're not making the triangle bigger or smaller here. And then choice 4 is a line reflection, followed by a second line reflection. You don't even need 2 reflections, you only need 1. So that's not our answer. Question 23. If triangle TAP is dilated by a scale factor of 0.5, which statement about the image of the new triangle is true? So when we're dilating something, we're making something bigger or smaller based on the scale factor. So since the scale factor is 1/2, we're going to be making this triangle smaller. Triangle T prime A prime B prime is going to be half the size of triangle TAP. So let's go through these answers one by one. Choice number 1, notice we're dealing with the angles. The angle of the new triangle is going to be equal to half of the angles of the old triangle. So anything with the angles and dilation, we're just going to ignore that because anytime you make a dilation, the angles are going to remain the same. And you'll notice the second choice is saying the same thing, or something similar with the angles. So we're going to just mark that wrong also, not our answer choice. Now let's look at the next one. So this is saying the original triangle is equal to 2 times the new triangle. So that makes sense to me because the scale factor is 1/2, then we're going to be multiplying the new triangle by 2, which they would cancel each other out and they'd be equal to each other. But let me look at an example. So let me just make up a point for t. So let's say a point for t is 8, 4. So if we're dilating something by a factor of 1/2, dilation of 1/2, we're really going to be halving each of these numbers here. So 8 becomes 4, and then 4 will become 2. So what we're saying here in our example is we're taking t, the original t, and then we're saying it's equal to 2 times the coordinate point of the new, or the x value, and then 2 times the y value for t prime, which will give us 8, 4. So that's our answer. Question 24. In the diagram below of triangle ABC, x and y are points on AB and AC, respectively, such that angle AYX is equal to angle B. Which statement is not always true? So what we have here is a case of similar triangles, of this little triangle AXY to this bigger triangle ABC. So I'm just going to separate them out so we can get a better picture of them. So just taking AXY and just rotating it a little bit, taking it out here, and then we're going to take this bigger triangle ABC. And when I'm drawing triangle ABC, I'm just going to make sure that the congruent angles y and b are in the same spot. So y is over here, so we're going to put b over here and c over here. So we have congruent y and b angle, and then they both share this A angle, of course. So triangle AXY is similar to triangle ABC by angle. So knowing that, we know we're going to have proportionate sides. So now let's look at our question, which statement is not always true? So let's go one by one and see which makes sense. So choice 1, we're saying AX over here to AC over here is equal to XY, the base, to the base of the other triangle. So that works out. So since it is true, it's actually not going to be our answer. Let's try choice number 2. So let me erase this. So we have AY, this side of the right side of the smaller triangle, to AB, right side of the bigger triangle. A is equal to AX to AC. So right to right is equal to left. So that is also true. That is not our answer. So now choice number 3 is a little more difficult to think about because they want to step ahead and start cross multiplying. But let's take a step back and put it in that proportion that we know it's equal to. So if we have AY, so we know we're going to have a proportion. We're going to have AY times CB, right? Because they're next to each other. So we're going to put them diagonally across from each other. AY times CB. And then let's see what makes sense. We have AY over here is equal to AY over, let's have XY down here, the base. So AY over XY, the base, is equal to AB over CB. Now does that make sense? So we have AY, the left side of our shorter triangle, is equal to the left side of our triangle, of the bigger triangle. And then XY, the base of the smaller, is going to be congruent to the base of the bigger. So this makes sense. So this also is not our answer. So by process of elimination, our choice is choice number 4. But let's look at why. Let's make sure this makes sense. Okay, so let's do the same thing for choice number 4. And let's set up a proportion. So we know we're going to have this format. We know AY. Actually, let me write it over here so there's more room. So we know AY is going to be across from AB, diagonally across from AB, so they're being multiplied by each other. And then we'll have AC and AX diagonally across from each other. So let's look at this. So AY is over here. Let me erase this. So we have AY over AC. Okay, so now notice we have the right side of the little triangle and then the left side of the triangle. So already this is not looking good because you want both sides to match. Is equal to AX to AB. So they have their sides mixed up here. So AX is the left side of the little triangle and then AB is the right side of the bigger triangle. So we know that this is no good and is not always true, and choice 4 is our answer. So this is the end of part 1. So if you're looking for more on this test, check out the playlist in the link below. And thanks for stopping by. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!